Hi, this is Boniface Honjala, or you can call me Bonnie the Tech. I am an IT and physical security system specialist. You can reach me via the email address below. I'm going to show you how to configure inter-VLAN routing on a router, or what we call router on stick. First of all, let's basically, or rather briefly, go through what a VLAN is and what inter-VLAN routing is. A VLAN allows several networks to work virtually as one LAN. Devices within a VLAN can communicate with each other without the need for routing. Devices in separate VLANs require a routing device to communicate with one another. Basically, a routing device can be a router or a layer 3 switch that has a routing capability. These are new breeds of switches. I'm talking about Catalyst 3750, 3560, 3550 series, which incorporate routing capability within the switch. And they are also called layer 3 switches. Layer 2 switches, which are Catalyst 2950, 2960 series, and small business switches, require a layer 3 routing device or a router for it to actually for you to configure an inter-VLAN routing. The device is either external to the switch or another module on the same chassis. To forward out the packets to different VLAN from one VLAN to another or broadcast domain, inter-VLAN routing is needed, and that is why it's very important for us to know how to configure this. Configuring inter-VLAN routing on a router is called router on stick. Why configure VLANs on your network? Basically, these are the advantages of having VLANs on your network. One, it's about security. VLANs greatly enhance network security. By actually creating VLANs, we can control broadcast domains, set up firewalls, restrict access, and also VLANs can be used to inform the network manager of an intrusion. Number two is performance. The network traffic is full of broadcast and multicast. By creating VLANs, the broadcast or multicast packet will go to the intended users only, thus reducing the need to send such traffic to unnecessary destinations. Flexibility is also one of the advantages. VLANs provide flexibility to add, remove the number of hosts we want. The number of small size broadcast domain can be increased, which are easy to handle as compared to a bigger broadcast domain. We also, by creating VLANs, we also reduce cost. VLANs can be used to create broadcast domains, which eliminate the need for expensive routers. Before watching this video, I am just assuming that you have the following basic knowledge or background. You have knowledge in computer networking. You have a basic understanding of network protocols and their ports. And finally, you have an understanding of the OSI and TCP/IP models. Welcome. I'm going to use a packet tracer as my simulator, just to create a VLAN and show you how to do inter-VLAN routing. On my simulator, I'm going to use this IP 10.50.0.0, SIDR 23 for VLAN 1, and then 10.50 SIDR 23, that makes 2.3.2.0 SIDR 23 for VLAN 2, and 10.50.4.0 SIDR 23 for VLAN 3. I'm only going to create 3 VLANs, and I'm going to call okay, VLAN 1 is default, we're not going to change that. I'm going to call VLAN 2 as technical. VLAN 3, I'm going to call it security. Now I'm going to use switch 2960 series, and let's have our host computer. Let's have three computers. Sorry. Let's call these PC1. I'm going to give this an IP.50.0.5 SIDR 23. We're going to assign these on VLAN 1. Sorry. Call this PC2, IP.10.50.2.5 SIDR 23 VLAN 2. Sorry again. PC3 10.50 dot VLAN 2, okay, dot 4.5 SIDR 23 VLAN 4 VLAN 3, and let this be PC. Okay, there's no need for this. There's no need for this. Sorry. Delete this. Let's get into our switch CLI and configure our VLANs to that switch. First of all, we need to enable, and then go into configuration terminal. Then okay, first of all, let's see how does the VLANs look like. We have only one VLAN created by default, and the ports are from 1 to 24, and we have gig ports, port 1 and 2. So yeah, let's quickly create VLAN 2. Let's quickly name it as technical. Yeah. Let's quickly create VLAN 3. Name it as security. Then let's quickly assign our ports to our created VLANs. And so I'll start with VLAN assigning port 10 to 15 to our VLAN 2 and 15 to 24 to our VLAN 3, and the rest of the ports will fall under VLAN 1. So now we say range, int range, interface, that's actually interface range of our port number 10 to 15. Let's get our switch port mode to be access. Sorry for that. Switch port access, VLAN 2. Let's assign the other ports to VLAN 3. That is from port 16 to 24 to 24. Let's get the assignment, switch port mode, access. Remember, I'm using a layer 2 switch 2960. So let's bit together on that. Switch port mode, switch port access, VLAN 3, and we can try and see what has happened now. Yeah, we have our VLAN 1 as default, VLAN 2 as technical, and assigned port 10 to 15, VLAN 3 security with active ports 16 to 24. And so let's quickly define our trunk ports. Int range gig sorry, 111 range, that switch port mode trunk, switch port trunk allowed VLAN all. Let's now see what we can write. Save the config, just doing a command write, or you can do copy running config startup config. Then let's show running configurations. Oh, sorry, that's by default. I've not assigned that. Okay, by default the first one port 1 to 9 lies under VLAN 1, and the rest will go to VLAN 2. Sorry. Let's go back to our config. terminal mode, int range 501 to 9, switch port mode access, switch port access VLAN 1. And let's now show running config. See, there's no difference. Basically it picks VLAN 1 as default, and now there's nothing else we're going to do here. We're just going to check to assign the IP addresses on our hosts and connect the host to specific switch ports. Let me just save this last config that we did. I was just showing you that there's nothing that can change even if you try to change to configure to assign ports to a default VLAN as of this. It's just a switch port mode access anyway. Let's see. I'm going to assign this to VLAN 1. We come to our connections and select copper straight through cable, VLAN 1, port 1 to 9, so any port is okay. VLAN 2 to port 10 to 15, so port 12 is okay with us. Then this goes to VLAN 3, any port between 15 and 24. So let me take 16. Let's now try and check whether these VLANs can communicate without any further steps that I'm going to show you. Let's assign IPs as we had earlier defined. This is 10.5.0.5, side at 23, that means 255.254.0. that will have a gateway of 10. Okay, fine, just leave at that. This is under VLAN 2, 10.50.2.5, 55.254. It's okay. This is under VLAN 3, 10.50.4.5, 255.254. Now to just prove that hosts within same VLAN can communicate, let me just add one host under one VLAN, say VLAN 1 here. Let me just do this and add this under VLAN 1 and give it an IP, give it that is 10.50.1.5. let's give it that. Let's give it the IP. And so this PC4 I mean PC4 has IP 50.1.5 SIDA 23 under VLAN 1. This means this host, this PC here, can communicate with this PC without further steps or without doing anything else. Just what we've done. We've just created VLANs, and so far devices in the same VLANs can communicate, but you cannot have devices on different VLANs to communicate at the moment. And to prove that, let's just have this host ping 10.50.0.1.5. yeah, in fact this PC can reach this one without any hassle, without any problem, but you can try reaching these other PCs on different VLANs. And let's see now if we can reach 2.5. Nothing will happen. Yeah, we can try 4.5. Nothing will happen. Yeah, and so this is now where inter-VLAN routing comes in. The switch is 2960 series. It's a layer 2 switch, and for us to initiate or to configure inter-VLAN routing, we are going to introduce a router. I'm going to use 2901 series router. And yeah, let's just have a connection to our gig 0 and have it to our trunk port 1. So we have introduced our router, and we're going to create what we call sub interfaces. Let's open our CLI and just say no to that and enable that. This is just a basic guide to administrators, IT system administrators, or startup network administrators. This is a quick guide. Let's get into our config terminal and now create our interface, sub interfaces. I mean, we create our sub interfaces, each sub interface linking to a VLAN, and give it an IP address as follows. We'll say int let's just first of all see what is on our router, show VLAN if it is there. By default we have one. Yeah, and so go back to our config terminal and say int gig 0 0. Let's not give it IP address, no IP address, that our port, and then let's direct it not to shut. So it's up. Now let's create our sub interfaces under that port, under that interface 0. Our sub interface will come as follows. That's gig 0 0.1 to represent our sub interface 1 is up. Encapsulation, remember these are commands that you have to remember. .q, assign it to VLAN 1. Sorry for that. Encapsulation dot then let's give it IP address. This is now our gateway for our gateway that for all our VLAN 1 devices. That is 10.50.1.254 10. Then our subnet, yeah, tell it not to shut. Let's create our second sub interface. Our second sub interface is 0.2. It's up. Let's have our encapsulation .1q, assign it to 2, VLAN 2, and give it an address, our gateway now, under which all VLAN 2 devices will be routing to via that IP address. That is 50.3.254. Subnet is 255.255.254.0. No shut. Remember, it's not a massive exit, but I'm used to it anyway. Let's create our last sub interface. Our last sub interface comes on this manner, that is .3. It's up. It's up. Remember our encapsulation .1q, assign it to VLAN 3. Then our IP address, that is 10.50.5.254, add subnet 254.0. Let's align not to shut. We can now save our config. Or do copy running config to start up, and let's show running config. There we go. Our first sub interface carries VLAN 1 and the gateway is 10.50.1.254. Our second sub interface carries VLAN 2 and the gateway is 10.50.3.254. Our third sub interface is carries VLAN 3 and our gateway is 10.50.5.254. And so yeah, just as simple as that for beginners. And let's now go back to it's, yeah, you can see now they're up. Let's go to our hosts and try to reach our devices on the other VLANs. So I'll try to reach VLAN 2. Let's first of all try to reach the gateways. The first gateway is 1 gateway on VLAN 1 254. Yeah, I can reach that. Let me try and see if I can reach the on VLAN 2. I can't reach that. Why? Because I've not assigned a gateway on this host. Okay, let's just give it its gateway, and let's do the same to these other ones. This is VLAN 2, so we're going to assign a VLAN 2 gateway. That's VLAN 3. We're going to assign VLAN 3 gateway 5.254, and that's VLAN 1. Going to assign VLAN 1 gateway. Now back to our hosts under VLAN 1. Sorry for that. Then come here. See, I'm reaching gateway on VLAN 2. Let me try to reach a gateway on VLAN 3. It's 5.254. I'm reaching that gateway. That means I can reach a device on these VLANs. Let me try to reach a device on VLAN 2. Yeah, it's there. On VLAN 3, yeah, it's there. Just to prove to you that. So you see, I'm able now to reach hosts on different VLANs. We can also do the same from these other PCs and try to reach a host on VLAN 1 and host on VLAN 3. Remember, I am working. I am on PC2. IP that on VLAN 2. So let me try to reach a host on VLAN 1. There you go. Let me try to reach a host on VLAN 2. VLAN 3. There you go. As simple as that. That's a layer 2 switch. These are your hosts and that's a router. So our inter-VLAN routing is done on the router 2901 series, and basically what we do is to create sub interfaces and assign those sub interfaces with the IP addresses that we call gateways, which will allow the VLANs to go through, to route through or broadcast their packets to other VLANs on the same network. Thank you, and if you have any queries, you can reach me via the email I shared before, and welcome.